This is second part of rational numbers class 8 mathematics. In this we start with additive identity. The additive identity of rational numbers is 0, right? So you take a rational number, let me take it as minus 5 by 4. When I add a 0 to it, I'll get the same rational number minus 5 by 4. So we say that 0 is the additive identity of rational numbers. Now we pass on to additive inverse. In the case of additive inverse, we take the rational number as 7 by 8. The additive inverse of 7 by 8 is minus 7 by 8. Similarly, the additive inverse of minus 7 by 8 is 7 by 8. When you add a rational number and its additive inverse, you will get the additive identity. Then we say that each rational number is inverses of each other. That is, the inverse of 7 by 8 is minus 7 by 8 and the inverse of minus 7 by 8 is 7 by 8. Now in the case of properties of subtraction, the closure property is true, right? So when I go to the closure property, the subtraction of rational numbers is a rational number. We will take 1 by 2 minus 1 by 4. So when you subtract 1 by 4 from 1 by 2, you will get 1 by 4. So take 4 as your LCM and it is 2 minus 1, that goes around 1 by 4. Again a rational number. So we say that the closure property is true under subtraction. Now we go for commutative property. In the case of commutative property, 1 by 2 minus 1 by 4 is not equal to 1 by 4 minus 1 by 2. So the commutative property doesn't hold for subtraction. And in the case of associative property, it is 1 by 2 minus 1 by 3 minus 1 by 4 will never be equal to 1 by 2 minus 1 by 3 minus 1 by 4. So even the associative property is not true under subtraction. And we pass on to the properties of multiplication. In the case of multiplication, the closure property goes like this. When you multiply 1 by 2 into 1 by 4, you will get 1 by 8, a rational number. Now we go for your commutative property. In the case of commutative property, it is 1 by 2 into 1 by 4, which is same as that of 1 by 4 into 1 by 2, which is nothing but 1 by 8, which is equal to 1 by 8. So the closure property is true and the commutative property is also true. In the case of associativity, we have three rational numbers, that is 1 by 2 into 1 by 3 into 1 by 4, which is same as that of 1 by 2 into 1 by 3 into 1 by 4, right? So this is nothing but 1 by 2 into 1 by 12. It gives me 1 by 24. Here the case is 1 by 6 into 1 by 4, that gives me 1 by 24. So under multiplication, the associativity is true. Now we pass on to the multiplicative identity of rational numbers. The multiplicative identity of rational numbers is 1. Supposing I take the rational number 7 by 8. So when I multiply 7 by 8 by some number, I'll get 7 by 8 as my product. So the number that I need is 1. We say that 1 is a multiplicative identity of rational numbers. Now we pass on to multiplicative inverse. The multiplicative inverse of a rational number, we take the same 7 by 8. The multiplicative inverse of 7 by 8 is 8 by 7, right? So when I multiply 7 by 8 and 8 by 7, I'll get 1, the multiplicative identity. So we say that 7 by 8 is a multiplicative inverse of 8 by 7, right? Now we go to an interesting fact. We take the number plus 1. The reciprocal of plus 1 is plus 1. When I take it as minus 1, the reciprocal of minus 1 is minus 1. Reciprocal is nothing but another term for your multiplicative inverse, right? So plus 1 and minus 1 are those two numbers which have their own reciprocals. This you have to keep it in mind. Now we'll go for the number 0. Do you think that 0 has a reciprocal? No, 0 doesn't have reciprocal. 0 has no reciprocal. Okay, now we'll pass on to the important property of this rational number, that is distributivity. So in the case of distributivity, we have distributive property of multiplication over addition and distributive property of multiplication over subtraction. So the law goes like this: A by B into C by D plus E by F is same as that of A by B into C by D plus A by B into E by F. So supposing if I have a negative sign over here, I will be having a negative sign over here. So I say that the first one is distributive property of multiplication over addition, and the second one the distributive property of multiplication over subtraction. So we'll take three rational numbers. We'll prove this, right? So I take 1 by 2, 1 by 3 and 1 by 4. Let me go for my LHS, which is 1 by 2 into 1 by 3 plus 1 by 4. So that goes around 1 by 2 into, again you can take LCM for this, 1 by 3 and 1 by 4. So your LCM is 12. So it is 1 into 4, that gives me 4. 4 plus 3. So it gives 1 by 2 into 7 by 12. So it goes around 7 by 24. Right. Now I go for my RHS. In the case of RHS, it is 1 by 2 into 1 by 3 plus 1 by 2 into 1 by 4, right? So it becomes 1 by 6 plus 1 by 8. Now I take LCM for the 6 and 8 as 24. So it goes around 8 plus, there are 6 in this, so 4 into 1, that gives me 4, minus there are 3 8, so 3 into 1 gives me 3. So it becomes, as it is addition, it is plus, so it becomes 7 by 24. See, my RHS, it is 7 by 24, and my LHS is 7 by 24, and my RHS is 7 by 24. Both are one and the same. So we say that the distributive property of multiplication over addition is proved by using these three rational numbers: 1 by 2, 1 by 3 and 1 by 4.